Hi guys, welcome to Links our YouTube channel. My name is Ram Mishra and I'm your online instructor. So what's in this video? In this video I will tell you how to configure Elastic Load Balancer in AWS Cloud via Terraform. So guys, let's begin the topic. But before start the lab session, we have to understand few points, which is what is ELB and how it is work for AWS Cloud Provider. So basically Elastic Load Balancing is automatically distributed or incoming application traffic across the multiple targets and virtual appliances in one or more availability zones. It's monitor the health of its registered targets and route traffic only to the healthy targets. Elastic load balancing scale your load balancer capacity automatically in response to change in incoming traffic. So guys, let's begin the lab session and create Elastic Load Balance in AWS Cloud Provider. So guys, this is my Linux terminal and currently I'm using Royal 9.0. So where I have installed my Terraform tool. So let me clear the screen for you. And first of all, I will show you the OS release version of this machine. See, Red Hat release, it's 9.0. So let me create a new folder for this Terraform project. So I start again with the mkdir project 1. Name could be anything, and let me open my Visual Studio Code software for configuring and deploying Terraform configuration file. So I go with my VS Code. So guys, this is my Visual Studio Code. Okay, so let me make it big for you. See, and currently I am in my project directory. So you can see that currently I don't have any file in this directory. It's a newly created directory. So start with the first step, which is create the provider file. So let me right click, create new file, provider provider.tf. Name could be anything, but the extension should be always .tf, that is Terraform format provider.tf. Okay. Now just double click, open the file, and first of all I have to start with provider. So in my case, provider is, I go with the AWS, and region, so in my case the region is AP South 1. Okay, now Control S to save this file, and I'm going to open a new terminal and run the command, first of all, terraform init. So let me make it large, terraform init. So this command will initialize the working directory containing Terraform configuration files and install any required plugins. So basically when you run the terraform init command, any plugin required such as the AWS Cloud Provider or any cloud provider, whatever you have mentioned in your provider.tf file, are automatically downloaded and saved locally into the current location from where you run the terraform init command. So in my case, it's the current location is .project1 directory. So once the installation will be successfully completed, we will get the .terraform directory here. Okay, so let it be completed. Give me a few minutes. See guys, it's a Terraform has been successfully initialized, and you can see that under my project 1 directory here I have one more hidden directory .terraform directory where required plugins are stored. Okay, so these are the files which is already downloaded from the Terraform HashiCorp site. Okay, so now I start with the move to the next step, which is where we have to configure few resource file for the Elastic Load Balancing. So I start with the security group file first. Let me close this terminal, and I'm back on my Terraform project directory, and here I start with new file, and the file is, name could be anything. I start with sg, so I said sg.tf, security group.tf file. Okay, so I have to start with the security group file. As usual, I told you name could be anything, but the extension should be always .tf. So for the time saving purpose, I have already written the code for security group in my document file. Let me copy from the code from there and I paste it here, and then I will explain the each and every term. Okay, so here it is my code. Let me open. Okay, let me copy and paste it in my Terraform file. So okay, now I will explain each and every term. See, I started with a resource. Resource is AWS underscore security underscore group, because I am going to create a security group resource, and I assigned identical name, that is ELB underscore SG or -SG. It could be anything as per your as per your need or as per your requirement. So then I mention name is ELB-SD. This is my security group name. Then I define incoming traffic. So ingress rule. So ingress rule, I'm allowing two port number 22 for the SSH as well as the port number 80 for the web services. So from port is 22, the to port is also 22. Protocol, that is TCP based protocol, and CIDR block, in you can replace it with your IP address. So I start from anywhere. So I start for allow for all traffic from anywhere sources. Then I have to mention the outgoing traffic. So outgoing traffic, I start the block egress block, and from port is 0, protocol is -1, to port is also 0, and the CIDR block is 000/0. That means from allow from all traffic. So this is how you can create your security group file. And then the all code, whatever code I am mentioning here, it is mentioned in your Terraform registry.io site. You can copy from the code from there, and you can just modify the things as per need of the organization and put a paste here. Okay, so let me control as this file and run the Terraform validate command to check the syntax first. So I open a terminal and let me run the Terraform validate command. See, success, configuration is valid. Now I'm going to run the Terraform apply command. It will create one security group source in my AWS Mumbai region. Okay, but before run the command, let me show you the current status of my Mumbai region. So if here it is my AWS console, guys, and currently I'm in Mumbai region. And see, guys, I'm going to refresh the EC2 dashboard. You can see that currently I don't have any available instances here. That instances is 0, or any kind of load balancer is 0, or you can see any extra group except the default one. The default one is the security group, which is the default one to which associate with this particular region. So now I'm going to run the Terraform apply command from my Visual Studio Code terminal, and but it is not advisable that you directly run the Terraform apply command. First of all, we have to review the execution plan before deploying on the AWS cloud provider. So for this, I'm going to with Terraform plan command. Let me go with Terraform plan first. So when I run the Terraform plan, let's see what happened. Okay, see, plan 1 is going to be added. If I scroll up, see, this is the security group, AWS underscore security group dot ELB-SG. So if I go with this plan, it will add one new resources. So after you review your execution plan, time to apply your changes. So for this, I use Terraform apply command. So I go with Terraform apply and press enter. It will ask for the confirmation. It will ask for the prompting. So if you are sure about that, then you can type into the value, say yes, and it will take little bit time. And see, AWS underscore security group ELB is creating, and now it's completed. So you can see that resources 1 added successfully done. So I can view my resources entries from Terraform state list command. Also we have a Terraform state list. We can verify our resources, whatever the resources we have done through the Terraform. See, it's already done. Even I can verify my AWS console also. So if I open my AWS console and refresh one more time, see, currently I have 2 security group. If I open my security group, see, ELB-SG is there. If I select it and scroll down, you find out, see, on the inbound rules, we can check that port number, SSH, and port for protocol TCP, and the port SSH and HTTP is allowed for the incoming traffic. So this is how I just created one security group resource in my AWS region. Okay, now move to the next step, which is where I need to create 2 EC2 instances with web services. So I'm back one more time on my Terraform setup. So I just close this terminal. Here I am one more time. So I'm going to make a new file for EC2 resources. So let me again go with the new file, type ec2.tf, name could be anything, extension should be .tf, and I open this one. So again I have to create the put up the entries for EC2 resources. For this I have already noted down in my document file. So I again copy and pasted code from my document. Here it is. So this is for EC2 instances. So let me copy, and now I'm going to explain. Let it be paste first. Okay. So now time to explain. So in the line number one, I comment out that I mentioned that what I'm going to do, I'm creating a first web server, or this is a kind of first server. So resource this time is AWS underscore instances, and identical name is first name. It's just a reference name, so you can put up anyone, whatever you require. Then I have mentioned the AMI ID. This AMI ID is clearly mentioned in AWS Web Console, so you can just copy and paste it here. Then instance type is t2.macro. I go with the free tier account, and key name. The key name is in my case. This key should be automatically available on your region. So if I go with the Mumbai region, see key pair, under my key pair the is already available, so I just copy the key name from there. Then I mentioned the security group, so I have already created a security group named ELB-SG, so it is the ELB-SG string whichever I have pasted. What does it mean? It means during the creation of this EC2 instance is automatically attached this security group, whatever I have already created in my SG section. See, ELB-SG is there. Okay, so now then after I have mentioned a field user underscore data. So user underscore data argument after my key name, I have mentioned here to just mention my script which is going to create my first web server. So I started user underscore data and the frame, and then I started bin bash shebang, mention few commands like install the httpd, start the httpd services, as running the check config command to make it permanent on across the next reboot. Then I mentioned the echo command and just write down only one line. This is first web server to the where www.html index.html, and then I close the end of frame. And then I mentioned a tag name is could be anything as per choice. I mentioned this is my first web server, and I mentioned one more tag, source is equal to Terraform. So on this basis of source I can identify how many instances is created through this Terraform resources. Okay, then similarly I create another second server. The same options are there, only the differences is in the line, that is a second line number. So this is the second web server, which is mentioned in index.html file, and the identical name this time is second, AWS underscore instance, and the reference name is second. Rest of the things are the same, and you can I go with the same AMI ID. You can go with the another different AMI ID. It's totally up to you, and I just use the main resources file. Okay, so let me save one more time and open the terminal. So let me check the syntax one more time. So I have a command terraform validate. Once I run the terraform validate, let it be checked. See, configuration is valid. Now run the terraform plan command and check the resources. So I go with the terraform plan one more time. Plan 2 to add. See, it says if I go with this plan, it will create 2 new resources. So that's exactly I want. So I go with this plan with the help of terraform apply command. So I run the terraform apply, and if you are sure about that, you can use a small key auto approve. So if you use auto approve, it will not prompt you. Okay. See, plan 2 to add started AWS underscore instance first dot creating dot second dot creating. So you can see that my 2 EC2 resources is going to be deployed in my AWS cloud provider, and it will take little bit of time. Let me go to my AWS console. Here it is. Okay, let it be complete first. Still creating. Okay. Yeah, apply completed, resources to edit. So now you can see if I refresh my EC2 dashboard, earlier there was nothing, it's 0. Now if I refresh it, see it's 2 instances there and it is in running condition. Okay, so if I click to my instances, see first web server, second web server, and if I select the first web server and go to the security, see it is a member of ELB-SG security group, whatever I have created through my Terraform file. Okay, so it's perfectly working fine. I have installed my 2 instances through Terraform. So go back again on my Terraform console or Terraform environment. I just close that terminal. Now move to the final step, which is even we have the option. Let me show one more time with the terminal. Let Terraform state list. We can check that. Earlier it was only one security group entity. Now we have instances into instance first and instance second. Okay, so Now move to the final step, which is create my load balancer resource file. So let me again, I create another new file, say elb.tf, elastic load balancer. Name could be anything, I told you. And again, I have to copy the code from my source file. So I just copy it. Give me 1 sec. And let it be pasted here. Okay, now time to explain this field entries. Okay, so let me start with the first one. So I have started a hash create a new load balancer, just mentioning that I'm going to create a new load balancer. Then I mentioned the resource name. So this time resource is elastic load balancer, so I use AWS underscore elastic load balancer, and the identical name or reference name is Ram, could be anything, it's choice up to you. Then I started name is Ram underscore ELB. This is my load balancer name. Then I have mentioned the availability zone. So I am using Mumbai region. So in Mumbai region I use AP South 1A and AP South 1B. So the AGs, this is the AGs to serve traffic in. This is the required field for the elastic load balancer. Then I start with the listener field. So listener block. So what is the meaning of listener? Listener means this is a listener is a process that check for the connection request. It is configured with the protocol and the port for the front end and the back end connection. So I started with the instance port number is 80, for which I am going to configure this elastic load balancer, and instance protocol is HTTP, the web-based services. Port is this is the port number is 80, the port to listen on for the load balancer, and the LB underscore protocol, that is HTTP, that means the protocol to listen on. So again, instance port is, this is the port on the instance to route the load balancer. Then HTTP, this is the protocol to use to the instances. Then 80, this is LB port, this is the port to listen for the load balancer. And then finally I mentioned HTTP in the string format, that is this is the protocol to listen on. Then I go with the another block, that is health check. That is very important. So health check block defines basically load balancer perform health checks on all registered instances, whether where the instances is in the healthy state or unhealthy state. So I have mentioned healthy threshold. So healthy threshold means this is the number of check before the instance is declared healthy. Similarly, we have next one is unhealthy threshold. Unhealthy threshold means the number of checks before the instance is declared unhealthy. So in my case, I just put up the same entry too. You can change this as your own wishes or as your own needed. Then I mentioned the timeout. Timeout means the length of time before the check times out. So it says 5 time. And then the target means the target of the check. So in my case, this is the port number HTTP, and the port number is 80 and the protocol is HTTP. So I mentioned the HTTP colon 80, and then I mentioned finally interval. Interval means 30 seconds. So this is the interval between check the healthy and unhealthy check threshold values. Then finally I have mentioned another block, that is ELB attachment. So now I'm going to attach my instances to this elastic load balancer using instances. So I say instances, and under instances I mention AWS instances.first.id as well as instance.second.id, and I enable the cross load balancing feature. And ideal timeout, this is 40 seconds. So the time is in second that the connection is allowed to be ideal. And finally I mention a name, that is demo ELB. So if I talk about the instances, so AWS instance.first.id. So if I go with my ec2.tf file, see AWS underscore instance dot first dot id, similarly AWS instance dot second dot id. So whatever the instance id will be created through this is this file, it will be automatically called in this location using this parameter. So that's sufficient for this elastic load balancer file. So I'm just pressing Control S and open the terminal, and let me check with the Terraform plan. Terraform validate first. Terraform validate. Okay, configuration is valid. Go with the plan again. So if I press enter, let's see, refreshing the state. Okay, now see a plan 1 is added. So what is the current plan? What will the resource will be going to be added? See AWS underscore ELB.ram. Okay, so now finally I go with this plan. So I run the again Terraform apply command, APPLY --auto approve. So you can just pass the small tag or just entry, that is auto approve. So it will not prompt you. See, it's creating my load balancer. Okay, see, apply completed. Its resources done. We can check using the Terraform state list one more time. So Terraform state list. So once I press enter, see, load balancer is there, instance is there, first instance is there, second instance is there, and my security group is there. Okay, even let me go my AWS console and finally check from there. Okay, so here it is my AWS console, and see on my EC2 dashboard currently I don't have any load balancer. Here it's a load balancer 0. So now I'm going to refresh the screen, and here it is, load balancer is 1. Okay, so let me open this load balancer. If I click on the load balancer, look at that. You can see that my load balancer name is Ram_ELB and type is classic load balancer. Okay, and the availability zone is AP South 1A and AP South 1B. It is exactly the same one whatever I have mentioned in my TF file. And look at the status. That is the currently it is 0 of 0, 0 of 2 instances in services. So let it be wait. Let it be. Yeah, see, 2 of 2 instances in services. Okay, so time to check the load balance. How to check that? So what I'm going to do, I just copy the DNS name from here, let it be copy, and let it be checked. It is in, should be in active condition or a healthy condition. Yeah, it is in okay. So let me open the new tab, right click and paste the entry. So I just copy and press the DNS name from my load balancer, and I have opened another new time, and see, it's redirect my traffic into one instance. Let me refresh. This is the first web server. Let me refresh the screen. See, I'm going to refresh. This is the second web server. Again, if I refresh, see, this is the first web server. Again, one more time. See, this is the second web server. So guys, you can see that my load balancer is perfectly working and forward my traffic to the respective instances. So guys, this is all about this demonstration, and if you want to terminate the entire project, you have a command terraform destroy. Once you press the destroy, it will destroy each resources, whatever the resources you have created through the Terraform. So finally, it is the end of this topic. Hopefully you enjoyed and learned new things. Soon I will come up with another new interesting topic. Till then, keep practicing. Now I'm going to press yes. It will destroy my all resources. If you feel something I have missed or you wanted to know more something else, please leave your comment and subscribe my YouTube channel for more updates. If you like this video, please do not forget to like, share and subscribe my channel, and press the bell icon button for the latest update. Thanks for watching. Stay safe and goodbye.